Hi, I'm Olivia Kwan, and today we are doing the science experiment acidic patterns. This is the sodium carbonate solution.
So if you put 3 drops into the Petri dish, add the water just to cover the bottom of the Petri dish. Very good. Now we know from an earlier lesson that if the water is high hydroxide, there's more hydroxide than there is hydrogen, that water is what?
Basic.
It's a base. And does it have a high pH or a low pH?
It has a high pH.
So what do we do to test the pH in water, in a solution? How do we test it?
If you put some drops of thymol blue into this mixture, it should turn blue with a pH of 10.
Well, with a high pH.
With a high
right?
pH.
All right, we'll go ahead and let's see what mixing water and sodium carbonate solution, what it does to the pH of that water. And our theory is the water will turn
blue,
indicating that it's a base.
Yes.
All right, go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Very good. So we are already seeing that it's turning blue. Huh?
Yeah.
So stir that with your stick. So it's definitely a base, isn't it?
Yeah.
High pH. Now, do you have any sodium hydrogen sulfate?
Right here.
Yeah. Now, you know, that's an acid salt. So if we know it's an acid, it has a high concentration of hydrogen. Right. So I want you to just add 5 to 7 drops in different places all along the pH, all along the water that already has the thymol blue in it. So say 5 to 7 drops in various places.
1,
So
2, 3, 4, 5, 6.
that's good. So right when it hit, what color did that water turn?
It turned red and then turned into yellow.
So what would red indicate when you put thymol blue?
Red indicates it has a low hydroxide and has high hydrogen, and if it turns red, the pH is 1.
Well, it's low.
It's a very low pH.
Which we would refer to as what?
1.
An acid or?
An acid.
Oh, okay.
Because 9 and up is basic, and 3 and below is acidic, and through 3 and 8 and 3 and 8 are neutral.
Excellent. So we're still what here? Because it's still really blue. So even though we added a little bit of hydrogen to it and we could see it turn red, it's still blue, which means we're still what? We're still a base, aren't we?
Yes.
Well, we don't want a base. We want a neutral. We want a neutral. So we want to add something that adds in more hydrogen, right?
Mm-hmm.
So what did we just add that's high in hydrogen?
We added sodium hydrogen sulfate.
So let's add a few drops at a time, stirring, and you let me know when you've reached a neutral solution, okay? Have to be careful, because if you add too much, it'll turn red all over and you won't have a neutral solution, will you? You'll have an acidic solution. So you have to mix it up really well.
So once you have your...
So look, we're actually...
a little bit more because it turned orange.
So we're a little bit on the...
acidic side.
So what
but it's pretty close to the neutral.
But what do we need to add now to make it neutral?
We need to add sodium carbonate.
So maybe a drop. We were trying to get to neutral. And what color will neutral be?
Yellow.
Yeah, so we need to have a neutral solution. Oh, so we're getting...
See, it cleared up to yellow.
Yeah.
It should be about a pea color.
Maybe one more drop and you'll get... Or do you think that's enough to be completely neutral?
Let's try one more. But if it doesn't, we'll just add another.
But if it starts to turn green, then we're headed to basic, aren't
Yes,
we?
but if it turns green, we can just add one more drop of sodium hydrogen sulfate.
Let's stir that up. Maybe we'll be truly yellow.
It's starting to turn a little.
That looks yellow to me. So we now have a
neutral.
A neutral. Well, very good. Thank you, Olivia, for showing us how we can change the pH levels of water with specific chemicals.
You're welcome. Now that we've done our experiment, I'm going to tell you a few reasons why pH is important to the environment and to us. First of all, we have fish in their lakes or the ocean. If the pH is too low, the fish, when they lay eggs, the eggs will not hatch and they cannot reproduce. But if the pH is too high, they suffocate and die. So their pH level in the water, depending on the fish, has to be between 7 and 8. Second of all, we have plants. If the pH is too low, the plants cannot absorb the nutrients in the soil and will eventually die because of that. And the third reason why is we have stomach acid in our stomachs. So the pH can be between 1.8 and 3, and we have to have it very acidic so that we can digest our food. But when the food reaches our intestines, it's more of a 7 or an 8.
Thank you.
And those are the 3 reasons why.
3 examples.
3 examples.
Thank you.